Hey guys, so this part, second of the week, we're going to be looking at word problems with exponentials. So just as a quick review, with graphing, transformations are just like they were with quadratics, where the number with x is kind of backwards from what makes sense. So +1 is going to move it left 1, and a +3 is going to move it up 3 because that one's not backwards. Don't forget that this number is where my asymptote is going to be. So my domain is all real numbers, and my range is y is greater, than 3. To get the actual points, I'm going to go to GeoGebra. What was my equation? 3 times 2, 2 plus 1. Okay, so 3 times 2 to the x plus 1 plus 3. Enter. Okay. So that's what my graph should look like. I'm going to look at the table, which remember I recommend going from -5 to 5. And it looks like there's like about 3, maybe 4 points I could plot pretty easily. All I can do -2 and 4.5. -2, 4.5. Oops. Oh, -2. 4.5. -1, 6, 0, 9. Oops. -1, 6, 0, 9, and whoops, 1, 15. Okay, so that gives me a general shape. And remember that your graph should not cross or touch the asymptote. Ta-da! All right. Writing equations from a graph. A comes from the y-intercept, which in this case is 1. And then to figure out B, we have to figure out what do we multiply as we go up each time. So my next point that crosses at the corner of a box, I've got 3 and then 9. So if I go from 1 to 3 to 9, the pattern is that I am multiplying by 3. Excuse me. So to get the equation, I just put those together. So 1 times 3 to the x. Now, obviously, 1 you don't actually have to write. So the more proper way to write that would just be y equals 3 to the x. Okay, so moving on to the new stuff. Exponential word problems. As promised, we are pretty much just going to use a formula. So we're going to have y equals a, but instead of b, we're going to have 1 plus or minus r to the x. Okay, so we have to know what these things are. So a is your initial amount. Now, that could be obviously different things. I will go over some examples, but I suggest just writing this down. So A is your initial amount. R is your rate, which is basically going to be the decimal version of a percent. You'll do plus if it's increasing, minus if it's decreasing, which should make sense. And then x is usually going to be some time. You know, it depends on what the word problem tell you what you're going by. But anyway, there you go. So I recommend writing that down to have it. Because like I said, normally I could put it up on the board for you at school, but I don't have a board because I'm in a classroom. All right. So you deposit $1,500 in an account that pays 5% interest yearly. How much money do you have after 6 years? So in general, there's two steps. You want to write your equation and then plug in the number for x, because a lot of times the question will ask for the equation and then also ask for the answer. So my initial amount is 1,500 and my rate is 5%, which is 0.05. The way I tell people to remember percents, technically you just divide by 100, but think of it like dollars and cents. Like a percent is per 100. So, and just think of it like change. So 5% is 0.05. Like that's the same as like a nickel. If you put 0.5, that'd be 50%. That'd be crazy. Okay, so my equation is going to be 1,500 times 1 plus 0.05, because it pays, which means your money's going up, to the x power, which is the same as 1,500 times 1.05 to the x power. Okay. So to get my answer, how much money do you have after 6 years? I'll just plug in 6 for x. So I would say 1,500 times 1.05 to the 6. So I'm going to go over to GeoGebra. And I'm going to put 1,500 times 1.05 to the 6. Remember the exponent button is below the y. Okay, so since it's dollars, we would just round to the 2 decimal places. So $2,010.14. That's how much money you would have after 6 years if you had 5% interest on an account, which would be pretty cool, I think. Anyway, one more. Okay. A mouse population of 2,500 is decreasing in sizes at a rate of 20% per year. What is the mouse population after 3 years? So your initial amount is 2,500. Your rate is 20%, which is the same as 0.20. Again, think of it like 20 cents. And then, so my equation is going to be y equals 2,500 times 1, and this time it's minus because it's decreasing in size, 0.2 to the x power, which is 2,500. I forgot my 5. 2,500 times 0.8 to the x. So to figure out how many mice would be left after 3 years, 0.8 to the 3. So go back to GeoGebra, and I just type 2,500 times 0.8 exponent 3, enter. 1,280. And since there's nothing really to round because it's like 0.000 forever until you get to do whatever. But because we're dealing with like an animal, you wouldn't count like half a mouse. So you would round this, like try and be reasonable about where you would like either truncate or round by what you're talking about. Like with money, we did 2 decimal places because that's how we do money. With mice, it would be a whole number. So, well, I just forgot what it was. 1,280. Wonder why the mouse population is decreasing. It's no fun having a mouse. I once had a rat in my house. It's a crazy story. I'll have to tell you guys sometime. Anyway, don't forget to write down that equation, and I'll see you guys in the live meet.